The best way to know how to harden a web application is to know what its vulnerabilities are. The best way to discover that is to use a vulnerability assessment tool that is specific to web applications. One tool that does that is the OWASP ZAP project tool. ZAP stands for Z Attack Proxy. Now it's called a proxy because the idea is that for you to run an analysis against a web app, you need to kind of sit in the middle of a request being sent to that web app to monitor that request and the response. You can also simply just scan a web app for vulnerabilities, which is what we're going to be doing here. So before you can use the Z-Attack proxy, you need to download it on your machine if it's not already there. If you're using Kali Linux, for example, it's already built in, but I'm going to be doing this on my Windows host where, of course, it's not built in. So I've navigated to the appropriate website, zapproxy.org/download. And here I can choose to download it for the appropriate platform. For example, Windows 64-bit installer. Bear in mind that in order for this to install in Windows, you're going to have to make sure you have a Java Runtime Environment, or JRE, already installed. Otherwise, ZAP won't install. So after the installation is complete, it's just another app in Windows. Here I've got a desktop icon to start OWASP ZAP, or I could go to my Start menu, just like anything else I would normally do. So I'm going to go ahead and run that. So what do I do once the program is loaded? The first thing we want to do over on the right is run an automated scan. So I'm going to go ahead and click on that. So it wants us to specify the URL that we want to attack. Now I'm using air quotes because we're really doing this not as a malicious user, but as a security assessor. So we are, quote unquote, attacking it so we can find out the weaknesses that need to be addressed. So I'm going to pop in the IP address, or it could be a name, of my vulnerable website. And down below, I'm going to tell it that I want to attack. So I'm going to click attack. Now, as that happens, down at the bottom here, under the Spider tab, you'll notice that it's connecting to all aspects of the page. Really, it's looking at every page in that web app and looking at hyperlinks and what it points to, all the files. And of course, it's looking at the HTML on the pages, any JavaScript. It needs to be able to identify, are there weaknesses? It's even going to look at the version of web development components that might be present in some way on that web application server side. Because an important part of hardening a web app, of course, is finding out outdated components that have security holes that need to be patched. So now that we've had a chance to let this run against our web application, let's take a look at what it's found out. We can click on Alerts down at the bottom, where we can start to scan through what it thinks are weaknesses in the web app, such as application error disclosures. If we kind of click on that, over on the right, we'll get a description about what that means, such as a web page in the app perhaps reporting something that maybe it shouldn't. What it looks like it's doing is showing us the HTML over on the right in that web page for that web app that has some kind of a reference, a link, as in reference, to the parent directory. What we don't want on a web app, unless it's intended, is we don't want to allow file and directory browsing through the web application. That's a directory traversal attack, and we really don't want that unless the app specifically should allow that file system access. Vulnerable JavaScript library. If I click that over on the left, it's detected that. We can read the details about that. It says the library that you're using there is version 1.3.2, and there are known vulnerabilities for that. So now we know we need to update that. Now you can imagine that if Equifax had done this type of thing in 2017, they would have discovered that the Apache Struts component, that Java web development component, was out of date and known to be vulnerable, and they could have patched that to have prevented the entire Equifax breach. However, in all fairness, it's always, hindsight is 20/20, and always much easier said than actually done. Over on the left, a couple of other things that we have shown here. Private IP address information being disclosed. Remember that what we want to try to do to protect a web app is hide its true identity, especially if it's public facing. So we have a reference to that we might need to address. The reality, though, that I find in my experience in having done this in production many times is that I'm not a web developer per se. I do some web development, but oftentimes you'll be analyzing an app that you didn't write and that you don't really know all the details about because you're being hired to run some kind of an assessment. And that's why sometimes you'll have to take a screenshot or make a reference to what's seen over on the right, in terms of the web page or the piece of code that might be some kind of a security problem, and let the developers know. So just because we're the ones running this HTTP web server app scan doesn't mean we have to be the one that solves that same problem. It can be done by the software coders. And sometimes you need their expertise to make that happen, to be honest. So having done this then, we have a way to detect vulnerabilities in a web application. In this particular case, it's actually still in the midst of running a scan. So it's important to wait until the scan has had a chance to complete in its entirety before you can definitively say that you've properly scanned the app and you know what its vulnerabilities are.